Hello, myself Mohammad Asghar of CSE ANML is here to give a presentation and my topic is application of machine learning in recommender systems. The machine learning processes first, it identifies relevant data set and prepares them for analysis. Second, it chooses the data type of machine learning algorithm to use it. Third, it builds an analytical model based on the chosen algorithm. Fourth, it trains the model on test data sets, revising it as needed, then finally runs the model to generate scores and other findings. Who uses machine learning and what it is used for? Today, machine learning is used in a wide range of applications. Perhaps one of the most well-known examples of machine learning in action is the recommended engine that powers Facebook's news feeds. Facebook uses machine learning to personalize how each member's feed is delivered. If a member frequently stops to read a particular group post, the recommended engine will start to show more of that group's activity earlier in the feed. Behind the scenes, the engine is attempting to reinforce known patterns in the member's online behavior. Should the member change pattern and fail to read posts from that group in the coming weeks, then the news feed will adjust accordingly. What is recommendation system? Recommendation engines are subclass of a machine learning which generally deals with ranking or rating products or users. Loosely defined, a recommender system is a system which predicts the rating as user might give to a specific item. These prediction will be then ranked and returned back to the user. They are used by various large name companies like Google, Instagram, Spotify, Amazon, Reddit, Netflix, etc. Often to increase the engagement with the user and the platform. For example, Spotify would recommend you songs similar to the ones you have repeated listened or liked so that you can continue using their platform to listen music. Amazon uses recommendation to suggest products to various users based on the data they have collected from the user. Recommended systems are often seen as a black box. The model created by these large companies are not very easily interruptible. The results which are generated are often recommendation for the user for things that they need or want, but they are unaware that they need or want until they have been recommended it for them too. There are many different ways to build a recommended system. Some uses algorithmic and formulaic approach like PageRank, while others use more modalistic centric approach like collaborative filtering and content-based link prediction, etc. All of these approaches can vary in complexity, but complexity does not translate to a good performance. Often simple solution and implementation yield the strongest results. For example, large companies like Reddit, Hacker News, and the Google have simple formulaic implementation of recommendation engines to promote content on their platforms. Practically, recommender systems encompass a class of techniques and algorithms which are able to suggest relevant items to the user. Ideally, the suggestion items are relevant to the user as possible so that the user can engage with those items. YouTube videos, news articles, online products, and so on. Items are ranked according to their relevancy, and the most relevant ones are shown to the user. The relevancy is something that the recommender system must determine and is mainly based on the historical data. If you are recently watched a YouTube video about elephants, then the YouTube is going to start showing you a lot of elephant videos with similar titles and themes. Recommender systems are generally divided into two main categories: collaborative filtering and content based systems. Collaborative filtering systems. A collaborative filter is a process of predicting the interest of the user by identifying preferences and information from many users. This is done by filtering data for information or patterns using the techniques involving collaboration among the multiple agents, data, resources, etc. The underlying intuition behind the collaborative filtering is that if a user A and B have similar taste in product, then A and B are likely to have similar taste in other products as well. There are two common types of approach in collaborative filtering: memory-based and model-based approach. Memory-based approach, also often referred to as a neighborhood collaborative filtering. Essentially, ratings of the user item combination are predicted on the basis of their neighborhoods. These can be further split into user-based collaborative filtering and then based on collaborative filtering. User-based essentially means that the like-minded users are going to yield strong and similar recommendation. Items-based collaborative filtering recommends items based on the similarities between the items calculated using user rating of those items. Model-based approach are the predictive models using machine learning. Features associated to the data set are parameterized as input of the model to try to solve an optimization related problem. Model-based approach include using things like decision trees, rule-based approach, latent factor models, etc. Advantages. The main advantage to using collaborative filtering models is its simplicity to implement and then high-level coverage they provide. It is also beneficial because it captures suitable characteristics and does not require understanding of item content. Disadvantages. The main disadvantage to this model is that it's not friendly for recommending new items. This is because there has been no user items interaction with it. Examples. Some of the examples of collaborative filtering are YouTube content recommendation to user, recommending you videos based on other users who have subscribed or watched similar videos as yourself. Coursera course recommendation, recommending your course based on the other individuals who have finished the existing courses you have finished. Content-based system. Content-based system generates recommendation based on user preference and profile. They try to match the user to items which they have liked previously. The level of similarity between the item is generally established based on the attributes of items liked by the user. Unlikely most collaborative filtering models which leverage rating between the target users and other users, content-based models focus on the rating provided by the target users themselves. In essence, the content-based approach leverages different sources of data to generate recommendations. This simple form of content-based recommendation required the following sources of data. These requirements can be increased based on the complexity of the system you are trying to build. The item level data source. You need a strong source of data associated to that attribute of the item. For our scenario, we have things like book price, number of pages published year, etc. For the more information you know regarding the item, the more beneficial it will be for your system. User level data sources. You need some sort of user feedback based on the items you are providing recommendations for. This level of feedback can either be implicit or explicit. In our sample data, we are working with the user rating of books they have read. The more the user feedback you can track, the more beneficial it will be for your system. Advantages. Content-based model are advantageous for recommending items when they are when there is a insufficient amount of rating data available. This is because their items with the similar attributes might have been rated by the user, since a model should be available to leverage the rating along with the items attributes to generate recommendations even when there isn't a lot of data. Disadvantages. There are mainly two disadvantages. The recommendations provided by the obvious based on the items the user has consumed. This is the disadvantage because if the user has never interacted with the particular type of item, that item will never be recommended to the another user. For example, if you have never read the mystery books, then through this approach, you will never be recommended mystery books. This is because of the model in user specific and does not leverage knowledge from the similar users. This reduces the diversity of the recommendation. They are insufficient for providing recommendation for new users. When building a model, you have required a history of explicit, implicit user level of data for the items. It's generally important to have large data set of available to make prediction without overfitting. Some of the examples are Amazon product feed. You have been recommended the product similar to what you have previously purchased. Spotify music recommendation. There are many excellent content-based systems which are built algorithmically without the dependency of the model-based approach. For example, companies like HackerRank and Reddit have been known as previously used algorithmic approach to recommend new posts on their platform to the users. The key to building an algorithmic approach to the content-based recommendation lies in defining a set of rules for your business, which can be used to rank items. In this case, like Reddit, their recommendation are bounded by time of post, number of likes, number of dislikes, and the number of comments, etc. This can be factored into a formula to generate a score if the post is high score or would yield a high recommendation or a vice versa. This brings us to the end of the presentation. Thank you.